Here are the answers for some of the Chapter 6 review assignment. Starting with question 4, we're given a relation and we're asked for the domain and range. The domain is a list of the x coordinates, so these three numbers are your x values. I'm going to put the -1 first, and then the 0, and then the +1, just to put them in increasing order. The range is a list of the y values. -2 is a y value, and -3 is a y value. Number 5, we're asked for the domain of this function. The domain of any function could be all real numbers unless there's a reason to say that it's not all real numbers. And that can occur in a couple different ways, but in this problem what matters is that there's a variable in the denominator. We don't want the denominator to be 0, so what is the restricted value? What value of x would make the denominator be 0? And that is a 0. So our domain is all real numbers except 0. If you want to show that in symbols, you would simply write x is not equal to 0. Number 6, we're asked to make a graph of the ordered pairs x, comma, 1 minus x squared. And here are the values of x to use. Let's substitute all of those into our formula. -2 squared is 4, and 1 minus 4 makes -3. -1 squared makes 1, and 1 minus 1 makes 0. 0 squared is 0, and 1 minus 0 is 1. 1 squared is 1, and 1 minus 1 is 0. 2 squared is 4, and 1 minus 4 is -3. 3 squared is 9, and 1 minus 9 is -8. Now we can graph all the ordered pairs. -2, comma, -3 is left 2, down 3. -1, comma, 0 is right here. 0, comma, 1 is here. 1, comma, 0 is here. 2, -3 is here. And over 3 down 8 is here. Number 9, we're given a formula for function f of t. We're asked to evaluate it for different input values for t. So first let's plug in -1 for t. Every place in the formula where there's a t, fill in -1. Now let's evaluate. 2 times -1 makes a -2 in that spot. -1 squared makes +1, and -3 times 1 makes a -3 in that spot. -1 cubed makes -1, and subtracting -1 makes a +1 in that spot. When you add and subtract these numbers, you get -3. Now let's put 2a in place of t. And then simplify this out. 2 times 2a makes 4a. 2a to the second power makes 4a squared. And when you multiply by -3, that's -12a squared. 2a to the third power makes 8a cubed, and in front of that there's a minus sign. So here is the answer. Next, number 16. We have a direct variation situation. I'm going to create a proportion. I'm choosing to put numbers associated with f on the top and numbers associated with v on the bottom. One value of f is 15, and when f is 15, v is 3.9. Another value of f is 6.5, and when f is 6.5, we don't know the answer for v. Leave that as a variable. We can solve this proportion with cross multiply. 15 times v equals 3.9 times 6.5. Then divide by 15 to get v alone. The answer is 1.69. Question 17 is another direct variation situation. I'm choosing to put things associated with y on the top of the ratio and things associated with 5x minus 3 on the bottom. We're told that y is 18 when x is 3. Later, we're asked to find out what y is when x is 5. We can do a little bit of simplifying before we do the cross multiplication. This is 18 over 12 equals y over 22. Now let's use cross multiply. 12 times y equals 18 times 22. Divide both sides by 12 to get y alone. And the answer is 33. Next, number 19. Let's graph this function that has absolute value bars. One way is to make an XY table. Now, when you make the XY table, it matters what choices you make for x, because an absolute value, like a quadratic, will have a vertex point. And you have to make sure that one of the rows in your table at least includes that vertex. The graph of an absolute value that has a positive leading coefficient is a V shape opening up, where that dot right there is the vertex. Notice that this V shape has an axis of symmetry line, just like a parabola, and that the left branch will have dots that correspond to dots on the right branch. In an XY table, one of the rows needs to be the vertex, and then when you have numbers to the left and to the right of that vertex, you should see repetition in your y values. Let's choose some numbers until we see that repetition. One of the numbers I'm going to choose for x is a 0. 2 times 0 is 0. 0 minus 2 is negative 2. And the absolute value of negative 2 makes 2. Now I'm going to choose a 1. 2 times 1 is 2. 2 minus 2 is 0. And the absolute value of 0 is 0. Now I'm going to choose a 2. 2 times 2 is 4. 4 minus 2 is 2. And the absolute value of 2 is 2. Notice that I have that repetition of values, and so the 1 right in between is my vertex. This will be enough dots to get the graph. Here is 0, 2. Here is 1, 0. And here is 2, 2. Draw straight rays through those dots. You're making a V shape. You're not making a parabola for an absolute value function. Next, number 20, we have a system. So let's focus on the first one. We want to show where y is between 0 and 3. Notice also these little or equal to lines, which tell us we're going to draw solid boundaries. If I trace right along the x-axis, that's where y equals 0. If I trace a horizontal line crossing the y-axis at 3, that's where y equals 3. Y is anything in between there, so any shading I will do will be in between those boundary lines. But I'm not going to do any shading until after I've graphed these boundary lines. These also will be solid lines because of these or equal to's. So a vertical line crossing the x-axis through -1 is this boundary. A vertical line crossing the x-axis through 4 is the other boundary. I want to shade between my horizontal lines, but also between my vertical lines. That's this rectangular region in here. Number 25. We're asked to graph y equals -4x squared if the absolute value of x is less than or equal to 3. I interpreted that absolute value statement in its inequality format, using a topic from earlier this year. So notice on the x-axis, I've only taken the time to label from -3 over to +3. This is a quadratic equation. The value of a is negative, so I'm expecting a parabola opening downward. And my parabola is going to exist in between the negative 3 and the positive 3 for x. Let's make an xy table. Because there is no x term or constant term, the x value of the vertex is 0, and the y value of the vertex is 0. Let's choose negative 1, negative 2, and negative 3, and choose 1, 2, and 3. Substitute those values to see what y equals. I'm going to start by plugging in 1. 1 squared is 1, and negative 4 times 1 is negative 4, and this will be negative 4. Now I'm going to put in 2. 2 squared is 4, and negative 4 times 4 is negative 16, and here. And now I'm going to put in 3. 3 squared is 9, negative 4 times 9 is negative 36, and this will be negative 36. Now you can see why I labeled the y-axis down to negative 36. Let's find those dots. And graph in the parabola. There's not going to be an arrowhead because we want it to stop when x reaches negative 3. Number 26, we're told that price is directly proportional to the square of the weight. So I'm going to make ratios with price on top and weight squared on the bottom. One price is $1,521. And that price is associated with a diamond that weighs 1.8 carats. So 1.8 squared. Then it says, find the price, let's use x for that, for a diamond that weighs 1.2 carats. We can solve this with cross multiply. 1.8 squared times the x equals 1,521 times the 1.2 squared. Divide both sides by 1.8 squared to get the x alone. And the result is $676. Number 27. We're told that these two ordered pairs are solutions to this equation. We're asked to figure out what k is. If these are solutions, then these x and y values solve the equation. Let's plug in 2 and negative 3 for y and x. So we have negative 3 equals a times 2 squared. And solve this for a. A equals negative 3 divided by 4. Now we know the value of a, so we can rewrite this equation. Now let's go over to this second ordered pair, which we also know can be plugged in for x and y. So for the letter y, fill in negative 1/3. For the letter x, fill in k. And solve this for k. First step, I'm going to multiply both sides of the equation by negative 4/3. Because multiplying this fraction by its reciprocal will cancel it away. Negative times negative is positive, and 4/3 times 1/3 is 4/9. And that's equal to k squared. Now take the square root to get the answer for k. The square root of 4/9 is positive or negative 2/3. Here are the two possible values for k. The next couple questions use this function for function g. Number 28 says g of x is how many units below this equation. Notice that these are identical except function g has this -4 on the end. And so function g is 4 units below this function. Then we're asked for the axis of symmetry for function g. If you look right there, we can see that the value of h is -2. Because remember that this says x plus 2, that's like having x minus -2 when you think about vertex form. So the equation for the axis is x equals -2. Number 30 says, If x equals n is the vertex, and g of n plus 2 equals k, what is g of n minus 2? It would also be k, because a dot on the parabola that's 2 units to the right of the vertex will have the same y value as a dot 2 units to the left of the vertex. Number 32, we have this equation to start with, and we want to transform it into this format. I notice on the right side, we have a number factored out in front of something in parentheses. So that makes me want to factor this to get started. I'm going to take out the 2. I also notice that the form I'm trying to create has a binomial squared. I can create a binomial squared if I have a perfect square trinomial and then factor it. So let's make this be a perfect square trinomial. Take half of that coefficient value, that makes negative 3 over 2. And then square the negative 3 over 2. That makes 9/4. In this blank spot, put in 9/4. Now let's compensate for that, because if we only add a 9/4 on one side, the equation is no longer in balance. By us putting 9/4 in the parentheses, and because there's a 2 out front of the parentheses, we have really changed the value of the right side by 2 times 9/4. 2 times 9/4 is 9/2. So since we just added 9/2 to the right side, let's also add 9/2 to the left side. We will now have y plus 9/2 equals 2 times, and then let's factor the perfect square trinomial as x minus 3/2 squared. This has the look of what we're trying to create. Number 33, we have a quadratic equation. We're asked for the equation of the axis of symmetry. Remember, the basic formula is x equals negative b over 2a. A is 4 and b is 2. So negative b over 2a would be negative 2 over 2 times 4, which is 8, which reduces to negative 1/4. Our answer is x equals negative 1/4. Number 34. Here's our equation pattern, and we're told that the axis of symmetry is x equals 3. We're also told that negative 1, 5 is a solution to this equation. Find a and b. Remember that the equation of the axis of symmetry is x equals negative b over 2a. And we know that that turns out to equal 3. Let's solve this for one of its variables. I'm going to solve it for b. We have negative b is equal to 3 times 2a, which is 6a. Therefore, b is equal to negative 6a. Let's make a substitution into the equation. Y equals ax squared, and then minus 6a times x. If negative 1, 5 is a solution, then we can use negative 1 for x and 5 for y. Let's make those substitutions. We get 5 equals negative 1 squared is 1, and a times 1 is a, and negative 6 times negative 1 is positive 6a. So 5 is equal to 7a, therefore a is equal to 5/7. Once we know the answer for a, we can substitute it into the expression we had made that will find us b. So b equals negative 6 times 5/7, or negative 30 over 7. Now we know values of a and b. Number 35, we're asked to graph this parabola. This is in standard form, where a is 1, b is 5, and c is 1. Let's make an XY table and make sure the middle row of our table includes the vertex. The x-coordinate of the vertex is found with the formula negative b over 2a. So that's negative 5 over 2 times 1. This is negative 5 halves. Let's substitute negative 5 halves into our formula to find the answer for y. This makes negative 5 and 1/4. Now we can choose numbers to the left of that for x and to the right of that. Or, if you know the pattern of the dots for a parabola that has a value of a of 1, you can make the branches based on that pattern. That's what I'm going to do. When I label my x-axis, I at least have to get over to negative 2.5. And I'll put a few more marks even past that. On the y-axis, I got to at least get down to negative 5 1/4. Here's negative 5, and here's where negative 6 is. And I'll put marks going up. The vertex is at negative 2.5, comma, negative 5 1/4. The value of a is 1, so based on experience, from that vertex, I can go right 1 unit and up 1 unit. And there'll be a corresponding dot here. From this dot, I can go right 1 unit and up 3 units. And a corresponding dot here. And from this dot, I can go right 1 unit and up 5 units. 1, 2, 3, 4, 5. And a corresponding dot here. Number 36. Let's rewrite this so that the x² term is first. And graph it. There is no x term in the formula, so the vertex is on the y-axis. Because of the +4, the vertex is located at the 4th dot. Now let's use the value of a to get other dots. Normally you would go right 1, down 1, but you need to multiply that vertical change by negative 2. So I'm going to go right 1 and then down 2. From here you would normally go over 1 and down 3, but again the 2 here is going to double that. So I'm going to go over 1 and down 6. 1, 2, 3, 4, 5, 6. And here's the parabola. Finally, number 37. This will have a solid boundary and then some shading. Let's rewrite that so that the x² term comes first. We need to find the vertex of our parabola. Using the formula, x equals negative b divided by 2a. So that's negative 3 divided by 2 times negative 1, which is negative 2. This makes 3 halves, or 1.5. Let's get the y-coordinate of the vertex by substituting in 3 halves into our equation. We'll have negative 3 halves squared plus 3 times 3 halves. This is equal to 2 1/4. We could make an xy table to help us get the branches, but I'm going to use that the value of a is negative 1. Here's 1, 2, 3, 4 marks to the right, a few marks to the left. Let's put some marks going up and then some marks going down. The vertex is at 1.5, comma, 2 1/4. If the value of a is negative 1, you can go right 1, down 1 to get another dot, and a corresponding dot here. Then you can go right 1, down 3 to get another dot, and a corresponding dot here. We already decided it is a solid boundary line. This is the is greater than arrow, so you shade above the boundary.